Hello, A1 and A3 Chemistry. I told you that I would make a recording explaining the answers to the Unit 3 test review. So if you go to our Schoology page and then click on Unit 3, and then down at the bottom of the page there is a tab for Test Unit 3 Review. So if you click on that, this has an outline form, what we talked about in class yesterday, using the PowerPoint summary. So I will post the PowerPoint sometime later today, and right now I will go through this information. You'll need to either take notes or copy and print this out and then add the answers as we go along. All right, I have done that, and here is my version, and I just copy and pasted this into Word. I'm sure y'all know a lot of better ways to do it, and that's okay. So first, we learned about the structure of an atom and the subatomic particles that are found there, and then how do we describe those subatomic particles in the atom. In our homework assignment called Elemental Math, we focused on the information in the periodic table that describes the subatomic particles. So looking at our study guide, what is the definition of atomic number? The atomic number is the number of protons in the nucleus. So if you know the atomic number of an element or atom, then you know the number of protons. What is the atomic number of carbon? So to find the atomic number of carbon, we would go to the periodic table, and the number that is either on the top left or the top right or right above the symbol of the atom is the atomic number. So the atomic number of carbon would be 6. What element has an atomic number of 10? So we go back to the periodic table, we find the number 10, and so neon is the element that has an atomic number of 10. Another way to ask this question is, which element has 12 protons? If an element has 12 protons, then the atomic number is 12. So we go over to the periodic table, we find the atomic number of 12, and we see that that is magnesium. And if we scroll down on the elemental math, the element math homework, here is a summary of how to find the atomic number. It's up here at the top. All right. Atomic mass or mass number, they are used interchangeably, they mean the same thing. And what is the definition of atomic mass or mass number? That is the number of protons plus the number of neutrons. And if you know the atomic mass or mass number of an element, then you know the number of protons plus the neutrons. Example question 1, what is the atomic mass of nitrogen? So we go back over to our periodic table, we find nitrogen, and the atomic mass or mass number is always the number at the bottom on the periodic table. Okay, so nitrogen, the bottom number says 14.007. So the atomic mass or mass number for nitrogen is 14.007. And then once again on this element math homework assignment, we have that summary. The atomic number is the number on top, and the mass number is the number on the bottom. And the mass number is the sum of the number of protons plus the number of neutrons. Example question number one. Atomic mass of nitrogen, we found that on the periodic table. That's one type of question where you look to the periodic table to find the answer, but then other questions, you are filling in information of number of protons, number of electrons, number of neutrons, and I give you most of the information, and you have to fill in what's missing. So this is potassium, and the atomic number is at the top, and that's the number of protons. You would have to look on the periodic table to see what the name is with this particular symbol. So for that symbol K, we go to the periodic table, and we find the letter K, and it's right here, number 19, and it says that that name is potassium. So we could write potassium here in this line. 39 is the mass number or atomic mass, and that's the number of protons plus neutrons. So the number of protons is always equal to the atomic number. So the number of protons would be 19. The elements on the periodic table are always given as the neutral atom, and in a neutral atom we have the same number of protons as we do electrons. So the number of electrons would also be 19. Now to get the number of neutrons, we subtract the atomic mass and the atomic number, because the atomic mass is protons plus neutrons, the atomic number is protons. So if we take the difference, we are left with the number of neutrons. So the number of neutrons for potassium would be 39 minus 19, which is 20. Atomic structure. This information would be questions that ask you what are the subatomic particles. So name the 3 subatomic particles, the charge, the mass, the location, etc. And going to our Schoology page, we have a homework assignment called Structure of an Atom. And this homework has a summary of all of this information. All right, so let's go back to our study guide. Atomic structure. Name the 3 subatomic particles. Those are protons, electrons, and neutrons. The mass of a proton is 1 AMU. The charge of a proton is +1. The location of a proton is in the nucleus. The mass of a neutron is 1 AMU. The charge of a neutron is 0. It doesn't have a charge. And the location of a neutron in an atom is also in the nucleus with the protons. Mass of electrons is basically 0. The charge of an electron is -1, and the location of an electron in an atom is in the electron cloud. And a neutral atom has a charge of 0. And if an atom has a neutral charge, then the number of protons are equal to the number of electrons. So let's look at our elemental structure of an atom, homework. And we see this information here. We see that the neutrons and the protons are in the nucleus. neutrons and protons both have a mass of 1 AMU, and AMU is the unit. Neutrons have no charge, but protons have positive charges. Electrons have no mass, and they are found in the electron cloud. And for our neutral atoms, the number of protons equal the number of neutrons. So if there are 5 protons in the nucleus and 5 electrons in the electron cloud, then even though that atom does have charges within it, overall they cancel each other out, and that would be a charge of 0, and we would say that that is a neutral atom. All right, let's go back to our study guide. Then we learned about the periodic table and why the periodic table looks the way it does. So remember, the periodic table is, the original intention was for this table to be used by scientists working in the laboratory. So it's arranged so that it is useful for a chemist or any scientist. And it's also beneficial for you to understand the periodic table because there are many aspects of our daily lives where, as research is able to take us down on the atomic level, we see that as technology becoming smaller and smaller and smaller, and knowing about changes potentially in the environment, even with the pandemic, understanding on the atomic level what's happening is actually becoming more and more relevant. So the way this relates to you is you would be able to look at the periodic table and understand how reactive different elements are. And so this will be very helpful to you, especially as you get older and move out on your own and start voting in elections. So the periodic table, if we look on our Schoology page, we have a homework assignment called Groups and Periods. And if we go back to our study guide, on the periodic table, the elements are arranged by increasing atomic number, or the number of protons. So if we look at the periodic table, hydrogen is first because it has an atomic number of 1. Fluorine is 9th because it has 9 protons. It has an atomic number of 9. So these tell you the number of protons, and then the elements are aligned in order of increasing atomic number. All right, let's go back to our study guide. On the periodic table, how do you determine the number of protons found in one atom? How do you determine the number of electrons found in one atom? And how do you determine the number of neutrons found in one atom of an element? You will use, here we go. The element math homework tells you how to calculate the number of protons, the number of electrons, and the number of neutrons. If the atom is neutral, then the number of protons equal the number of electrons. If it's not, then you need to count the number of protons and count the number of electrons. Neutrons, you will always be able to calculate this number by subtracting the mass number and the atomic number. All right. This next couple of sections are using the Bohr model atoms to determine which period and which group an atom is in. So if we go back over to Schoology and we go to our groups and periods homework assignment, this homework reviews how to determine what period and group an element is in. The period describes which row. All right, so lithium is in period 2. Potassium is in period 4. Cesium is in period 6. And the period tells you how many energy levels there are in the electron cloud. So looking at one of the Bohr models, we can determine which period an atom would be in by looking at how many energy levels it has. So potassium has 1, 2, 3, 4 energy levels, and krypton also has 4 energy levels. And both of these atoms, for these elements, we should find in period number 4. So if we go back up to our image, we do see potassium here in level 4, and here's krypton, also in number 4. So to determine the number of energy levels, we either find what period it's in, and then we know it, or if we look at the Bohr model, we know by how many rings that tells us. And for the groups are these vertical columns. And the groups tell us how many electrons are in that outer level, and those are called the valence electrons. So the valence electrons are how many electrons are in the outermost energy level. So boron has 3 valence electrons, and we see that there are 2 rings, so that means boron should be found in period 2. So if we double check, there is boron. It is in period 2. Nitrogen, if we count the electrons in the outermost shell, there are 5. And phosphorus, if we look at the outer shell, also has 5 electrons, 5 valence electrons. So nitrogen and phosphorus both have 5 valence electrons. So we would expect to find them in the same group. And if we look on the periodic table, here's nitrogen, here's phosphorus, and the groups are the vertical columns, and so they are in the same group. They're in the same group because they have the same number of valence electrons. However, nitrogen has 2 rings, so it's in period number 2, and phosphorus has 3 rings, so it is in period number 3. If we go back to the periodic table, we see that that is true. Nitrogen is in period 2, and phosphorus is in period 3. There's only one way to name the periods, and that's by numbers, 1, 2, 3. But there are 3 ways to name a group. And one way is just by the cardinal or ordinal number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oxygen is in group 16. Cobalt is in group 9. Beryllium is in group 10. But we can also name the groups by Roman numeral. Now for the Roman numeral system, we're going to ignore the transition metals. So hydrogen is in Roman numeral 1 group, oxygen is in Roman numeral 6 group, helium is in Roman numeral 8 group. And then there is the family names as a way to name the groups. Our first column, except for hydrogen, are the alkali metals. The elements that are in a column with boron are called the boron family. The next to the last column are called the halogens, and the last group is called the noble gases. So these would be the element family names. Something else we can tell, looking at the groups, as I said earlier, are the number of valence electrons. And everything in a group together that's shown here have the same number of valence electrons. And these are also the same numbers as the Roman numerals. So for the Roman numeral method, 1, 2, 3, 4, 5, 6, 7, 8, that also tells you how many valence electrons there are. So looking at the noble gases, they're Roman numeral 8, and they have 8 valence electrons. Boron is in Roman numeral 3 group, and it has 3. This whole group has 3 valence electrons. All right, let's go back and look at our study guide. How do you determine which period an element is in on the periodic table? You count how many energy levels there are. If you know the period of an element, then you know how many energy levels have electrons. For example, an element in period 3 does not have electrons in energy level number 4, but does have electrons in energy levels 1, 2, and 3. How do you determine which group an element is in on the periodic table? You look to see what column it's in. And what does the group tell you about an element? If you know the group of an element, then you know how many valence electrons are in the outermost level. For example, if hydrogen has 1 electron in the outermost energy level, then we know that either lithium or helium also has 1 electron in the outermost energy level. So that would be lithium, because hydrogen and lithium are in the same group. All right, so that means they have the same number of valence electrons. And also, if oxygen has 6 electrons in the outermost energy level, then we know that either sulfur or fluorine, so we go back, we find the oxygen group. Sulfur is in the same group, so that means that sulfur also has 6 electrons in the outermost level. Isotopes and ions. So we did a few homework assignments covering this information. The homework assignment that is called Bohr atoms, isotopes, and ions, and then also our isotopes new chart homework assignment. Both covered this information. And the definition of an isotope is 2 atoms of the same element that have different numbers of neutrons. So if 2 atoms are isotopes, then they will have the same number of protons, but different numbers of neutrons. Another way to say this is if 2 atoms have the same atomic number and different mass number, then they must be isotopes. Ions are atoms that don't have the same number of protons and electrons in that one atom. So they have a charge. They don't have the canceling out of all of the charges, which would occur if you have the same number of protons and electrons in one atom. So if an atom is an ion, then the number of protons does not equal the number of electrons. A positive ion will have more protons than electrons, and a negative ion will have more electrons than protons. So if an ion has 2 more electrons than protons, then the charge will be -2. If an ion has 1 more proton than electrons, then the charge will be +1. So if we go over to our Bohr atoms, isotopes, and ions homework, I have that information summarized there, and we see that when we have more electrons than protons, we have a negative ion. If we have more protons, I may have said that incorrectly. If we have more electrons than protons, it's a negative ion. And if we have more protons than electrons, we have a positive ion, which is also summarized in this one image. There's also a review of the Bohr diagram and what the Bohr diagram tells you about an atom. Okay, that is in this homework assignment, Bohr atoms, isotopes, and ions. And then in the isotopes homework, it also gives more information about isotopes. And there will be a question that looks like this chart on the test. And this shows you the average atomic mass, which is the number that you see on the periodic table. Remember, the average atomic mass is a weighted average, and it indicates which isotope is most common on the planet. So, for example, the average atomic mass for lithium is 6.941. There are 2 isotopes for lithium. This average atomic mass is closer to 7 than it is 6. So that would mean that lithium-7 is the most abundant isotope of this element. So let's go back to our study guide. An isotope has the same number of protons. Each atom would have the same number of protons, but then those atoms would have different numbers of neutrons. So be sure to stress that the isotope definition is between 2 atoms, whereas the ion definition is just 1 atom. You're just looking at the 1 atom to determine if it's an ion, and you'll be counting the protons and electrons. With isotopes, you're comparing 2 atoms. And if they are isotopes of each other, then each atom will have the same number of protons. But the 2 atoms will have different numbers of neutrons. And that is the definition of an isotope. It doesn't matter how many electrons are in isotopes, and it doesn't matter how many neutrons are in ions. An energy level can be thought of as a location of electrons around the nucleus. An electron in energy level 1 is closer to the nucleus than an electron in energy level 3, and an electron in energy level 1 has less energy than an electron in energy level 3. Valence electrons, we've discussed already. Those are the number of electrons in the outermost energy shell. Now, this last group of information that you need to know, we can find this information in the homework assignment groups of the periodic table. You need to be able to indicate where the metals, nonmetals, and metalloids are on the periodic table. You need to know traits for metals, nonmetals, and the metalloids. Then you need to know traits of the different groups. And all of this information can be found here. in this homework assignment. It is also found in the PowerPoint presentation, so you can get that information there. And then also in the homework assignment groups and periods, if you go to the end of this homework assignment, the family names for the elements on the periodic table. If you look in the PowerPoint presentation, there are traits of the different groups by family name, and that is where you'll get the information for this section of the study guide. So once again, this number 11, you'll need to open up the PowerPoint presentation, and then at the end of the PowerPoint presentation there are the traits of the metals, nonmetals, and metalloids, and then the common traits of the different family groups as well. All right, if you have any questions, just let me know.